Next up, we would like to prove the identity that e to the negative ix is equal to cos of x minus I sine of x. We're going to do this using Maclaurin series. And so first we just state all of them. So e to the x, the Maclaurin series is the summation from n is equal to 0 to infinity of x to the power of n over n factorial. And that would be starting with 0, and this would become 1 plus x squared over 2 plus x cubed over 3 factorial, and you just keep going like that. Next up, we'd like to state what cos of x the Maclaurin series is going to be, and it is going to be the summation from n is equal to 0 to infinity of negative 1 to the power of n, x to the power of 2n over 2n factorial. These can all be found just using the formula evaluated at 0. So that would be negative 1, 0, x, 0, and just keep going. And so this would become everything to the power of 0 is 1. Minus x plus x squared over 2 factorial. Sorry, just one moment. The summation is going to actually work out to look like 1 minus x squared over 2 factorial plus x to the power of 4 over 4 factorial plus, and it goes on like that. And that's because of the fact that any odd number derivatives of cos are signed and evaluated at 0. That would cancel out the coefficient with a 0. That's why you have x squared, x to the power of 4, so on and so forth. Sine x, let's just finish this up, would be negative 1 n x to the power of 2n plus 1 over 2n plus 1 factorial. And so that would be the missing terms here. It would be x minus x cubed over 3 factorial plus x5 over 5 factorial plus continue. And so now we are going to put in e to the negative ix, and the summation should become 1 it should become 1 minus ix so 1 minus ix in brackets plus ix squared over 2 factorial plus ix cubed over 3 factorial and you continue that way. And then now we just need to use the properties of I. We know that I squared is equal to, I to the power of 2n is going to give us negative 1. I to the power of n is going to give us, 2n plus 1 is going to give us negative I. Because it would take out all of the to n and leave you with the -1 times I. And so what that means is all of the odd numbered powers here are going to become -1 in front of I, and all of the even numbered powers here are just going to become -1. And so when we write that out, that will become 1 minus ix minus x squared over 2 factorial plus ix cubed, is supposed to be plus ix cubed over 3 factorial plus x to the power of 4 over 4 factorial minus ix to the power of 5 over 5 factorial, and you go on like that. And now we are actually going to separate this into 1 minus x squared over 2 factorial plus x to the power of 4 over 4 factorial plus, so it's all of these even numbered terms that don't include an I. And I'm going to subtract off I, so the negative I that are in front of the other odd numbered terms, leaving x minus x to the power of 3 over 3 factorial plus x to the power of 5 over 5 factorial, and you go on like that. And we notice that these are actually summations that we know, namely the one that we wrote down for cos. And the one that we wrote down for sine. Except now, yeah, all over 2n plus 1. And so what that means is it will become cos x minus I sine x is equal to e to the negative ix. And that is what we're looking for initially, so it's been proved.